Hey, what's up, folks? How's it going? This is Abhijit here, and welcome to Devops Challenge Hub. So let's start with today's interview question. I'm sharing my screen. So explain how Kubernetes helps organization optimize workload distribution using an analogy or story. So how does Kubernetes helps organization optimize the workload distribution? So as usual, I will start with the concept. After that, I will show you a demo. Once you see the demo, the concept will be very, very clear. And at the end, we'll have quiz. Okay. So stay till the end, watch the demo so that concept is clear. So let's start. So Kubernetes helps organization optimize workload distribution using these features. So we'll discuss these features. First one is node selector or node affinity, teams and toleration, resource request and limits, horizontal pod auto scaling, pod anti-affinity. So they are the methods it uses to optimize workload distribution. So we have already discussed all this in previous sessions, like multiple interview questions. We have covered all these topics: node selector, trends and toleration, resource request limits, horizontal pod auto scaling. But today we'll see how to tell this as a story. If interviewer asks you a story, it's fine. But even if you tell it as a story with analogy, it will be interesting because interviewer will be also impressed. Okay. So let's say that you are in a, like, there is a small town called Cube Town, and there are workers. Workers are nodes. Workers are nothing but the nodes. And there are some tasks which are like pods. So some task happens, application runs, does some job, which does the job on the nodes. So worker does the task. Okay. And then mayor of the Kubernetes is called Kubernetes. And which this Kubernetes is a very smart guy. He can distribute the work. So how he can distribute the work? When you distribute the work, you have to look at the skill set of your worker, right? And you will see that this task this guy can do, this task another guy can do because he has that kind of skill set. So similar way, here distribution will happen. So node selector or node affinity. Here it's like a specialized set of workers. For example, when you do video editing or video optimization, video crunching, when you process the video, like services like Netflix, etc., like when they compress the video, optimize the video. So it needs a lot of power. It needs a special machine. Sometimes when it does upscaling, it needs GPU, right? Normal CPU won't do that. So you need a special machine. So what you can do in the node selector, will say video equal to true. So whatever nodes, whether they if they support if they are very high powered, they can support video processing like GPU and that kind of thing. So it will it will have that time. So it will be sending to suitable worker. It will be sending to the suitable guy. Suitable guy. Okay, this guy is a video editing guy. He can do this job, right? Next one is a tense and toleration. These are like a sensitive workers. He can't do everything. He will do only specific work. Like if it is the emergency work, then only he will do. Otherwise, he won't do. Any random work he won't do. So only emergency task he will be doing. For example, then he will say, tent himself saying that I want only emergency work. So Kubernetes agree will say that, okay, I will send a task which is a toleration for this tent. Okay. So this keeps not be focused on the critical work only. So this guy will focus on the critical work. Then second option is a resource request and limit. So here workers will say that, okay, when you're sending the work, tell me how much CPU you need, how much memory you need. You need only one core, but finally, like you, something goes wrong and you started demanding 5 core. That's not right because other guys, I need to help other guys also. Right? Or you need 500 MB normally. You initially said that I need 500 MB to do my work, and later you started demanding I need 10 GB of memory to do my work. That's not the right thing because other guys also working and you are eating up their resources. It will hog the machine, it will hang the machine. I can't tolerate this. So I will set resource request and limit. So So pod will be setting that request and limit. So this way you can optimize, right? You can distribute the load properly. So that way no worker gets tired and overworked. Everyone gets what they need. Fourth option is horizontal pod auto scale. So tasks that multiply. So website there are like 10 visitors. Tomorrow there are 10,000 visitors. After like few days, it's like there are 1 million visitors, right? So traffic keeps rising. So need to increase the number of pods. I will spin up more copies of the pod. So that way also it will optimize the resource. When we don't need there are only 10 visitors, again I will shut it down. So that way I will be using resources optimally. When I don't need 10 machines, why to keep running 10 machines? When I need only one machine, I will have only one machine because only one guy is visiting the site. If the 10,000 guys visiting, I will have a 10 machine. So that way I will optimize the workload. That is another way of optimization. Optimize the workload distribution. The last one is a pod anti-affinity. What is pod anti-affinity? It says don't put all eggs in one basket. In investment also we see. They say that, right? Don't buy all, or like if you have money, some like you want to invest money in the stock market, like don't put all your money in stock market just because it's giving good return, or don't put all your money into real estate. Distribute the money, right? Distribute your investment in stock, in uh, real estate, in gold, right? Don't put all eggs in the same basket. So if that basket is broken, all eggs will be broken. Similarly, if you get three tasks and if you have three nodes, one node maybe can handle a 10 tasks, but you won't give three tasks to one node only. That's because it can handle 10 tasks. We will give one task to one node. We will spread across so we will make sure that it's spread. These pods are spread across multiple workers using anti-affinity rule. Using anti-affinity. The first one we said select affinity, attach, but here anti-affinity. If it's already done, I won't be putting the pod next pod here. Put it to the next one. Okay. So this is anti-affinity. So hope this is clear. So let's have a look at the example. So we'll optimize the workload distribution. Let's assume that organization runs two types of workload. One is like high priority CPU intensive jobs, video processing, which needs a lot of CPU, a lot of memory. Other one is a low priority, like some small web app. It has some static pages, so it doesn't need high power machine. Okay. So let's say you have a organization has two machines. One is a very high power machine, other one is a kind of low end machine. Okay. So we have to ensure that CPU heavy jobs are scheduled on the high performance nodes, and also ensure lightweight apps don't compete for CPU. Lightweight apps should not be like put in a high power machine. So here I have installed client cluster on my machine, on my Mac laptop, and kubectl. And in the kind cluster YML, I have mentioned that I want to create two workers. I want to create two workers, worker one, worker two. Okay, because I want to create two nodes. So I've already done that. And kubectl get nodes. You can see there are two nodes are there. Two nodes are created, like worker and worker two. Okay, worker and worker two is there. So let's assume one guy is a very high power machine, other guy is a low power machine. Okay, worker two is there. So we'll level it. Worker one is a high power. kubectl level node, kind worker high power guy, high performance guy. Other one is like a standard. Other one is a standard. Kind level node and worker two standard. Okay. Now I have to I will create two deployment. Okay. So let's have two deployment. One is a video processing. Video processing. Video processing. It needs high performance. It needs high performance video YML. So it's a deployment. Name is video processor. Later is a video. Container is a name is processor. Image is busybox. And it needs CPU this much, memory this much. And node selector type is high performance. We put a level there, high performance. So it should be on high performance node. Another one is a regular web app. Regular web app. Regular wave app on standard. Regular wave app on standard one. 100 CPU, millicore, and MI 128 megabyte. Standard. So deployment, I have to do the deployment now. kubectl apply -f video, then kubectl apply -f web. Both deployment is done. Now I have to verify the distribution. Record here. A kind worker. This is the like a high performance video processor, high CPU. So video processor running there. Wave they're running on this kind worker 2. It's a low power. Here I'm just running a Docker like the two. It's just a two Docker, same power here, but I'm simulating that like real life situation. I don't have high power machine. I have only one Mac machine here. On that, I have created two virtual nodes actually. But in real life scenario, we will have two different machines, like high power machine and low power machine. Okay. So benefit of this approach avoids resource contention, better performance for CPU intensive jobs, like the your like job it takes more power to assign to that machine, right? GPU machine or high power CPU machine, 8 core to 32 core machine. Right? Efficient use of infrastructure, scalable and adaptable. So these are the benefits. So these are the different ways you optimize workload distribution on Kubernetes. So let's have a look at today's uh, quiz. I hope you like this video. Please like it. This will motivate me to create more such videos like this. And I will also get a feedback that you are liking this video and this is way you want the videos. So please pause and like it. Okay, let's have let's look at the quiz. Which of the following Kubernetes feature help optimize workload distribution across a cluster? Node selector, node affinity, taint toleration, resource request limit, horizontal forward auto scaling, forward and T affinity. We know that it's all of them. All these are required to optimize workload distribution across a cluster. Okay. So please subscribe to my YouTube channel and also follow me on my LinkedIn page, Devops 𝐤𝐞𝐫𝐢𝐞𝐬. I post quiz daily. You can participate in the contest and also follow my WhatsApp channel, Devops 𝐤𝐤𝐫𝐢𝐞𝐬𝐤. Thank you for watching this video and see you again in the next video.